Welcome back. We are ready to start getting real feedback from the NV32. And the first thing that we're going to do is we're going to think. And let's just start by observing how the NV32 responds to us telling it what to do. When we poke the button, you can see that when we select Nate's wireless, it changed to HDMI 3, but our box that we were interacting with, that control, it also updated to the new string, i.e. the pretty name. So here's what we should expect when we are trying to think through how to handle the event handler of the NV32. When we're thinking about it, we need to think what happens. What happens is the NV32 gives us a new pretty name. We are going to have to translate the pretty name into a friendly name. And then lastly, we are going to want to update the dot string of the list box. So this is our plan. So let's start writing the event handler. The event handler, and we'll write the first one and then we'll figure out how to do it scalably, just like we did before. We're going to start with its name, dev NV32. We are going to look into that component's control, the one that we're interested in, which is, you may remember, we just used it up here, HDMI.out.1.select.pretty.name. And then what about that control are we interested in? Previously, it was the dot string, but here we are interested in its event handler. And as you would expect, it's a function. We're going to pass in CTL, and because we opened it, we are going to close it. And let's start off simply by making use of funcdebugger to make sure that what we think is going to happen is indeed what's going to happen. So let's use func video debugger. All right, it needs arg who. All right, who is who? This is going to be the NV32 out number 1. And what did it? DTL.string is the input that got picked. And why did this happen? This happened because the device updated. So now when I hit save, I can change the NV32, and I just put it on HDMI 1. So as we see here, the debug tells us that the NV32 out 1 routed HDMI 1/nil. Oh no, nils. Remember nils? We said nils are a problem. Nils are a thing that we actually need to prepare for. And so why did we actually get a nil here? Well, we didn't get a nil when we routed from our UCI, but we are getting a nil when we go to look up in the table. Remember, how does func video debugger work? It works by passing in the input string and then looking up the translation of that input string. In the NV32, we are sticking in a pretty name, and it doesn't know what the corresponding friendly name is. And so in our table, if we try to index our table with the key of the pretty name, guess what it corresponds to? Nothing. It corresponds to nil. This debug is already giving us a clue about what we need to do to make step 2 work. The clue is telling us is that there is no entry in our table Babelfish for that key. So we made in table Babelfish a translation that mapped the friendly names to the pretty names. And so all we need to do is make the reverse definitions as well. So let's do it. Let's add our reverse definitions into table Babelfish. Here's how we're going to do it. We simply add more entries into our table. So we are going to right? If we wrote that the UCI variable is friendly HTML1.string is HTML1, we're also going to put in an entry that says that the string HTML1 corresponds to that UCI variable. UCI.variables.friendly HTML1.string. See how we're doing this? We are putting it in this way and then also this way. This way we can look up in either direction, and this is going to clear up those nils in our lookups. So we want to map the string HTML2 to the corresponding UCI variables. So here it is, UCI.variables.friendly HTML2.string. And again, table Babelfish, bracket quotes, HTML3 is going to map to UCI.variables.friendly HTML3.string. Now, for those of you who are saying, oh my gosh, Jeff, you are typing so fast. Well, one, yeah, sometimes I do type fast. But secondly, remember to make use of your autocomplete, make use of those tabs. Also, you can hit pause and you can catch up. I don't mean to be going fast. I'm just trying to write at a natural pace. So, and lastly, table Babelfish, bracket quote, well, bracket quote, graphic 3 is going to map to UCI.variables.friendly graphic 3. Also, we're doing all of this within func set choices because remember, this is where we're doing all of the updating and changing of everything that we need to do when UCI variables change. And since our table is dynamically being defined, we need to rewrite it every time we change one of those variables. So now let's hit save, and let's come back down to our event handler, and let's make some more choices. Now look what the debugger says. Instead of saying /nil, it knows now that when it routed HTML2, it also routed Nate's other laptop. It knows the name in both directions. We've made Func Video Debugger work for us in both directions because we made table Babelfish work in both directions. All right, all we did was we made a dictionary and we looked up the answer. We didn't have to do any searches. There's no loops involved. We just looked it up. So that's step 1. That's step 2. Let's get step 3. Here's step 3. We want to update the dot string of our list box. Now, we could reference our list box in 2 different ways. We could say controls.listoutbox1.string equals ctl.string. We could do that. But remember, we want to write the code scalably. We haven't really written it scalably at the moment, but we do ultimately want to write it scalably. And so remember, we put those list boxes in an array. We can reference it in the array of list boxes. Here's what I mean. Instead of writing out controls.listout1, etc., we can simply reference our list box, bracket, in this case 1, because we haven't figured out how to write this scalably yet, right? But the first control in the array of list boxes, we want to update its dot string to be what? To be table Babelfish's ctl.string. And when we do that, we can hit save, and it's working. When I make choices on the NV32, it is making those corresponding updates on our list box, as you can see here, right? When I choose HTML1, Nate's laptop is now being selected. If I choose HTML2, now it shows that Nate's other laptop has been selected. Aha, so here we go. We now have it working in the backwards direction. When we make changes on the NV32, our UCI is being updated. Let's see it work in both directions. In fact, I'm going to clear this debug so that we can see super clearly. When I pick from the NV32 directly, I get one debug print in my script. And it says the NV32 routed HDMI 1 / Nate's laptop because the device updated. Cool, that makes sense. That should be expected. All right, let's clear that. And now let's make a selection from our UCI. If I choose Nate's other laptop, notice how I get two debug prints in my script. Here's why I get two. I get the first one because the list box is telling the NV32 what to do, and that makes a debug print. And then also the NV32 does what it's told to do and tells me that it did what I asked. I'm getting two debug prints in this manner. And this is delightful because it's telling me exactly what's going on. And I definitely have very clean, clear information that would help me in my deployment and debugging of things. Now, lastly, can we do this scalably?
Surely the answer is yes.
Surely the answer is yes. And by now, you probably might be thinking to yourself, well, I remember how we did it for the array of list boxes. We defined our own array of list boxes, and we stuck them into an array of list boxes, and then we were able to do an I-pair loop. And I'm going to tell you, you absolutely can do it that way. But as you probably expect, I'm going to show you a different way because, again, I'm trying to show you the breadth of the tools in your toolbox. We have done a lot of work with the generic for loop. This is a really good opportunity for us to use a numeric for loop. So let's make this thing scale. Here's how we're going to do it. We are going to write the following. We're going to write for I equals 1, 2, because we only have 2, do the following, and we're going to put all of this event handler business inside of the for loop, right? 1 and 2, right? Start at the beginning, go to the end. We know there's 2. Could we make that a variable? Could we do something different there? Yes, we could. We're not going to worry about that at the moment. But what we do want to do is, just like we did earlier, we want to replace all of the 1s with I's. So here we go. We're going to replace this thing with an I, and we're going to replace this thing with an I, and we're going to replace this number 1 with an I. And now we have the code that's going to write both event handlers within the one loop. So even here, it's still worth it to put our code inside of loops when we can, because it means that I didn't have to copy and paste. And this means that I am cutting down on the amount of work and rework that I have to do when I want to make changes. So there you go, hit save, and let's watch this thing work in both directions. So there's HDMI 1 on NV output 2. And there it is. This is working absolutely flawlessly in both directions. There you go. That's fantastic. And you've done it. We now are able to tell the NV32 what to do, and the NV32 talks back to us. We are always in sync. Now, why bother? Why bother getting that return information? Well, just because we are controlling NV32 doesn't mean that other things might not wind up in your system wanting to control the NV32. And at least this way, our script is always in sync with reality. And that's one of the goals you ought to have when you write your code. So with that, we're going to conclude this particular video, and I'll see you again in a minute when we do some automation.